So as this is the main algorithm behind the green corridor for emergency vehicles system. So in this, let's assume this as a four signal intersection. Okay. So in this we have four signals, and now we have a infrastructure unit which will be placed in one of the signal control box, which will be there in the intersection. And while placing the infrastructure unit, will calculate the center of the intersection and will find its latitude and longitude and code it in the infrastructure unit. And now, let's say an emergency vehicle, let's say an ambulance, is approaching from this side of the road. Okay, so assume this as a road. This is a road. This is a road. This is a road, and this is a road. So these are four roads, and there are four signals. So I said this as four signal intersection. So let's say the ambulance is coming from this side of the road, approaching this side, approaching towards the signal. Okay. So when ambulance approaches the signal in a particular or certain radius, the the onboard unit. So we have a unit or we have a microcontroller in uh, every ambulance or every emergency vehicle. So this unit will get its connection to the infrastructure unit, which we placed in the signal control box, which we placed in the signal control box. And once it reaches the certain radius around the signal, it will connect to the infrastructure unit and send its GPS data to the infrastructure unit. Now, uh, okay, the on successful connection, it sends the GPS data to infrastructure unit. Okay, after it's sent, the infrastructure unit, what it does is, we already find it a value, right? This center value 13.0827 and 80.2707. This is for example. Okay, the it subtracts this value with the value which is sent by the ambulance. Let's say the ambulance sent this value 14 and 79. So what it does is 13 minus 14. I'm just saying it approximately, and 80 minus 17. So this 13 and 80 values are the values which is stored in the infrastructure unit, and this 14 and 79 is the value which is sent by the ambulance to the infrastructure unit. Now, while subtracting this, we get the answer which is minus x and plus y, right? So by this, we can conclude that the ambulance is coming from this side of the signal intersection, and hence, what we'll do is we'll make this signal as green and other signals as red. So this all signals will be blocked. This all signals will be blocked, and only this signal is sent as set as green for the ambulance to pass through the signal. And once the ambulance passes a certain radius, let's say when the ambulance reaches this part, the signal will get back to normal state again, which is the state which was there before the ambulance arrival. So this is the main algorithm, and now we are going to see the circuit.
Guys, this is the hardware setup. This is a general hardware setup. We just made it for prototype. Okay, so this is STM32 board, and this has a Wi-Fi integrated in it. So we have used this. So and we have two STM32 boards. So this will act as the onboard unit, as I said there, and this will act as a signal intersection or infrastructure unit. So this will be set in the signal, and this will be in every ambulance or every emergency vehicles. So let's keep this aside for now. So we'll see the connections in the infrastructure unit. So these are the pins, like, right, these pins are the pins which are used to control the signals. So this is the breadboard, and in the breadboard, each of these LEDs, 1 2 3 4 LEDs signify each signals. So this is a signal intersection, this is a signal, this is a signal, this is a signal. So there will be three LEDs in each signal, right? So red, green and orange. So I don't have enough pins to set it up, so I've just set it like this. So each LED signifies each signal. So now these pins are the pins, Arduino output pins, which is used to control the LEDs, as I said before. So now we'll come into this onboard unit. So what happens is, come here. Okay. So what happens is, as I said before, the ambulance approaches. So on the approach of ambulance, in particular radius will code a particular radius. So in that radius, this board will be connected to the infrastructure unit, and then what happens is it will send the GPS data to this thing, and the what whole thing I said before happens. So it uh, calculates from which quadrant of the signal the ambulance comes from. The calculation and other things will happen from this box, and this box is just for sending the GPS data to the infrastructure unit. So that's all is the thing of this box. And in future we are also planning this to integrate with an website called in an app called ERS. So it will be announced soon. So this is the main thing for this, and this is the infrastructure unit. So this is a simple hardware setup. There is nothing big in this. So as of now, the complexity is how we are going to connect these two boards. Now for demo purpose, we have used same network, so that we have connected this through Wi-Fi. So since the both of the boards are connected in same network, so it's not a big deal for us to control the signals or send the GPS data to this board and that board. So in real time we are going to implement UDP protocol, and through that we are going to connect these two onboard unit and infrastructure unit. So this is the simple hardware setup, and now we'll look into the code.
And this is STM32 Cube ID. So this is used to program the STM32 boards. And now here we have two codes. Okay, so one is the server code. Server is nothing. So this whole system is like server and client only. So the vehicles, right? The emergency vehicles are the clients, and the signal units or the infrastructure units are the servers. So nothing but the client is requesting the server to give the green signal for them. This is the whole thing, and here is the code. So this is the code for the server, or that is the infrastructure unit, which is going to place the signal interceptor. So now here I'm going to just explain some simple things. This whole code is some complex stuff. This is not complex stuff, but this is some HTTP related code. So just to host the server in the port. So the whole code is for that. But our sole purpose is to just demonstrate the green corridor thing. So now, as I told before, while placing the board in the signal box, we'll calculate the center latitude and center longitude of the signal. So we are seeing that the center latitude and the center longitude. And now here, this is like C code, so you can understand this. And this is the main. This is the driver code. So here I'm just going to show the algorithm, our own algorithm. These other things are the like example things which I took from the inbuilt thing itself. So now these are the initializations of each LED. So we have connected signals in LED in Arduino output pins, right? So we have initialized this here. So this is the code for that. So I'm going to just explain the main code. So see this control traffic signals thing. So this is the entire function which is going to take control of the signal. So on connection of a successful connection of the client to the server, what it happens is the client shares its latitude and longitude data to the board. So wait, I'll show you that. So, guys, when on the successful connection of the ambulance or the emergency vehicle to the infrastructure unit, it shares the latitude and longitude data, and that latitude and longitude data is received here. So, you see this latitude and longitude data. So, this data is received from the infrastructure unit. So, this data, after receiving this data, I'm going to descale this. I'll say why I'm going to descale this latitude and longitude value. In these two lines, I'm going to extract the latitude and longitude from the post request or the request I got, and this is descaling process. I'll say why I'm descaling the received value. So and after finding the rescaled value, I'll just pass it through this function control traffic signals large scale long scale. So I'll just pass this to that function, and now there is this function. So in this function, I'm going to receive the descaled value, and now I'm going to calculate the delta x and delta y. Delta x and delta y is nothing but the what the thing has said. So I'm going to subtract the values which I received with the values which I already coded in the system. So this is the thing. And now if the delta x and delta y, delta is difference as we know. So we are going to find the difference between the latitude and longitude we got and we already saved. This is the second time. So if the delta x and delta y is both greater than 0, and we know that the ambulance is in quadrant 1. In the quadrant 1, the red signal, I'm just don't bother about this comments. So I'm going to open the particular signal and close the other signal. And delta x and delta x less than 0, delta y greater than 0, which indicates that it is in the left side quadrant, like the quadrant 2, upper left. Okay, so it's in the quadrant 2. So now, similarly for other two quadrants, we have to find the case and we have to open the particular signal and close the other signal. So this is the main function to take control of the traffic signals. And after the connection is cut, that is the connection is cut between these two boards, the signal will be or the function or the thing will be directly handed over to the previous previous state in which the signal was in with a minor delay, of course. Yeah, there will be some delay for going to orange light and then to red again or green whatsoever. So this is the code for the server. So now we are going to go to the client. So this is the code for the client. That is the onboard unit. So in this, you see this is the remote IP I've calculated, not calculated, but I've got. So this is the IP of the server. But in real time, we'll not know the IP of the server, so we have to follow a entirely separate protocol, that is UDP protocol for that. But I'm not implemented it for now. We'll be implementing in future. So this is IP in which you're going to give the request to, or post the data to. Okay, so in this, I'm going to post the latitude and longitude. You see, latitude and longitude to the server book. So this is the post request body. I'm constructing the post request body here. So I've descaled a particular value there, right? So it's because of this. So the board which I'm using, the particular board which I'm using, STM32 LM475 or something, it doesn't support this thing like float scaling. So we have to manually scale the float or integer, the float thing to integer, and again descale that. So that is why we are scaling this here, and after receiving the value, we are descaling. So it is a particular fixed value, 10 to the power 6. We are scaling with that, and we are descaling that. That is actually this board doesn't support the float formatting thing, that percentage point to f thing we do in C, right? So that thing it is not supported here. So we have to multiply it with a number and then descale it with the number. So the constant number is 10 to the power 6 here. So that is why I'm descaling this. And then I'm posting the request to the server, to the remote IP which I found there. So this is the entire thing happening behind the scenes, behind the system. And the other codes are just for just simple things for connecting through Wi-Fi and making a post request and other things. So these are the main codes which we have done, and the other codes are typical. You can find it out anywhere. So this is typical general codes, and these are the codes which we rewrite. We wrote or something. I don't know. Yeah, so this is the code, and now we'll see the demonstration.
Now we're going to see the demonstration of the system. And so, come on. So I've just hard coded the values of the latitude and longitude, the current latitude and longitude of the ambulance or whatsoever emergency vehicle. So let's say now the ambulance is in this latitude and this longitude, and it has been connected to the, or it's going to be connected to the infrastructure unit and going to send the data from the from the onboard unit to the infrastructure unit. So now the value you see here is 14 and 79.02. When you subtract these values with the hard code or the center values of the signal, you see when you subtract these values of the 14 and 79 with the center values, you will get a negative of x and positive of y. So this will be in the negative, although the second quadrant of the signal. So now the yellow light should be turned on. So this is our desired thing. So yellow light means the signal, this signal, the second quadrant signal should be open and the other signal should be closed. That is, the other light should be off. So now let's try this. Come here. I've already loaded the code in the board. So this is the onboard unit. So I'll just already loaded the code. So I'm just going to reset this so that I'll observe it from the first. Before that, I'll go to the Terra term. So this is the server terminal, and this is the onboard unit terminal. So we'll just place them here. So now I'm going to show you. Now I'm going to reset the board. So see, I've resetted the board. You can observe the things here. So the board has been connected to the, you see here the CECP connection opened successfully. The board has been connected to the server successfully, and then it has made a post request. This is the post request format which we built, so that now you can see the second, that is the second quadrant light, yellow light has been glowed. So now this is just explanation. So this is the server terminal. Here you could have got the value somewhere, but we couldn't find this in the logs, so it's somewhat big. So now we'll try this for another quadrant. Let's say we're going to try this for the quadrant of 13 and 17. That is red. So the first quadrant. So now let's change the value. Let's change the value to 13, and this baby 79. So now we're going to debug and load the code into the system or the onboard unit again. So it will take some time, but in future you will going with the UDP protocol, so that none of this will matter. So yeah, the code is getting loaded. Yeah, so the code has been loaded into the thing successfully. So now here you can see that the red light has been glowed, that is, this quadrant light has been glowed. So guys, now we are going to see for the fourth quadrant, that is plus x and minus y. So we'll change this value. We'll change this value to 13 and 81.02. So now let's see, I'm debugging, waiting for the debugger thing. Now debug is successful. I got no errors, and now I'm running the program. So now now you can see here. So you can see that the fourth quadrant or the fourth signal quadrant's light, the green light has been successfully ignited or something. So this is the entire demonstration of the system. And so by this way we prioritize emergency vehicles, providing them first priority among all other vehicles without affecting the signal systems or the public. So yeah, this is green corridor for emergency vehicles. Thank you.